So today we're doing question 543 of LeetCode, diameter of binary tree. The question is, given the root of a binary tree, return the length of the diameter of the tree. The diameter of a binary tree is the length of the longest path between any two nodes in a tree. The path may or may not pass through the roots. The length of a path between two nodes is represented by the number of edges between them. So example 1, the tree has a root of 1 with a left child node of 2 and a right child node of 3. 2 has a left child node of 4 and a right child node of 5. The output is 3 because 3 is the length of the path. So between 4, 2, 1 and 3, 1, 2, 1, 3. That's a length of 3. 5, 2, 1, 3. 5, 2, 1, 3. That's also a length of 3. So the diameter is pretty much the furthest gap between two nodes. So the way we do this is by doing a depth first search of post order traversal. So we start from the left subtree, then the right subtree, and then the root. And we count each time we find one. We count one, and we check the max gap, and we set it to the max. And we do that each time. So we set check the max between left and right. We add 1 each time we find one, and we count the max gap pretty much. So let me show you how we do it in a whiteboard. So we do this in post order traversal depth first search. So we go left subtree first, then right subtree, then we return the root. So then return the max. So currently, or before we start, we have a base case. So if we get to an empty node here, like left child node 4, we will return 0. So we're given the root at 1. 1. Can we go left? We can. So now we're at 2. Can we go left again? We can. So now we're at 4. Can we go left again? No. It's null. Can we go right? No, it's null. So we return 0 for these. Then from 2, we go back up to 2. Then we go down to right at 5. Can we go left? No. Can we go right? No. So we return 0. Go back up. So on the left subtree, we return the current node plus 1. So now 4 to 2 is 1, gap of 1. Do the same for the right. 5 returns 0 because it had no nodes. So we go back up. 0 plus 1 is 1. So from 2, the left is 1 and the right is 1. So the max we set to the current max or left plus right. So left plus right is 2. Is 2 bigger than 0? Yes, it is. So we set the current max as 2, which represents the current diameter, because from 4 to 5 is a path of 2. So 1 and 2. Now, let's go forward. Okay. Now, from 2, go back up to 1. Now from 1, we go right to 3. Check if we can go left. No. Can we go right? No. So we went back up to 3. We return 0 here because we found no nodes. Then from 3, go back up to 1. We return the 0, so the previous node plus 1. So 0 plus 1 is 1. So now we're back at 1. And the left is 1. We found 1 at 2. So 1 plus 1 is 2. So left subtree is 2. So 2 plus 1. Is 2 plus 1 is 3. Is 3 bigger than max? Yes. So we set the current max as 3. And now, as we traverse the whole tree, we know we return the max, which is 3. We know the biggest gap between two nodes is 3. So 4 to 2, 2 to 1 is 2, 1 to 3 is 1. So 2 plus 1 is 3, as you can see, biggest gap. Now let me show you how it's done in code. So the first thing we do is we create a variable of max. We initiate it to 0. Then we create a depth first search function. So DFS, where we pass the root as a parameter. Now we create the base case. So if there's no root, or root is null, we return 0. So we don't count that as a path. Now we get the left value. Left, which represents the depth first search of the left subtree of the current node. We do the same for the right. Depth first search root dot right. Then we set the max as the current max, as a max between the current max, or left plus right. because this will show the gap between the current gap between the left and right subtree. Then we return the max between left plus 1 and right plus 1. So each time we go left, we find 1, we increment by 1. Each time we go right, we increment by 1, we return the max. So current node's gap. Then we execute the function, so root, and we return the max. Let's submit. Well, let's run first, see if it passes. Should pass. Perfect, let's submit. So this is a time complexity of O(n). As we're looping through the whole tree, worst case. No, we are looping through the whole tree pretty much. And it's a space complexity of O